Hello everyone and welcome to another reaction video. Today what I will do is I will read through an InfoQ article called Software Architecture. It might not be what you think it is. I find this very interesting. It's a very interesting topic that we often touch in our courses on software architecture, and we notice that people don't really get what software architecture is and isn't. And so I thought about reading this article and commenting through it, because I think this will be an interesting exercise for anybody who is either an architect, wants to become an architect, or is working with architects. So in either of these situations, it's probably very good to know what to expect. This article was written by Pierre Pureur, experienced software architect, Kurt Bittner, VP of Enterprise Solutions at Scrum.org, and reviewed by Thomas Batts, Senior Principal Software Architect at Blackbaud. Now I'm gonna switch very quickly to a better view. All right. Let's see. There are a few key takeaways. This is a list of things that we will go through. Software architecture needs to be wrested from committees of people disconnected from developing and to put it in the hands of the people who can actually make it real and executable, the developers. Only then will we have the resilience and sustainability that we need from today's applications. I agree, but with some nuances, so we'll see. Software architecture is about capturing decisions, not describing structure. True, although you need both. So yeah, this sounds very interesting. Architecting is a skill that Agile teams embody, which means that architect should not be a role. I mean, that would be the ideal, but I'm not sure it always works. And I've seen situations in which it works, I've seen situations in which it doesn't work. So we'll have to see. Architecting means continuously exploring new approaches and different alternatives to best meet quality attributes. Yeah, absolutely. This is the first statement that I agree with without any concerns. This is absolutely correct. The key activity of architecting is forming hypotheses about how the system will meet quality attribute goals and then using empiricism to test whether the system meets them and then repeating the loop until the system meets its quality goals. This is correct, although the problem with that is that you are continuously trying to hit a moving target. The quality goals are not fixed. I mean, the quality goals will change depending on what happens in the market and what happens with your product. For example, just a simple example, let's say you decide to have a certain scalability factor. Let's say, okay, we have good performance up to 100 users per hour. Just, some random number. And this is what you initially consider, but then you realize that you have a very good product, many people come to you, or something happens and people migrate to you, like what happened with Zoom in the beginning of the pandemic. Before that, there were people using Zoom, but then it grew very quickly because much more people needed a communication tool that was easy to use by teachers, by non-technical people. And suddenly your quality goal becomes, okay, we need now 1 million users per hour. This it's good, but it's not the whole story. The quality goals change. Now let's go through, because this is mostly a summary, let's go through the actual article. Software architecture has a contentious reputation in the Agile community. It is the cause of valueless meetings and irrelevant documentation that is aptly summarized by the expression, the map is not the territory. Okay, yeah, that's fair to say, although it's not only in the Agile community. It's I've seen good architects setups. I've seen bad architect setups even before Agile. And yet applications with poor architecture can quickly become like vehicles abandoned by the roadside, broken and unrepairable. So is there a useful middle ground between these poles of pointlessness? Oh, interesting way of putting this. Part of the problem is that architecture is an inane method for the result of the work of architecting software systems. Inspired by the work of building architects, the work conjures images of beautiful designs that hit that utopian futures. Not, well, yeah, I disagree. I mean, I agree that the building metaphor is wrong. And we should stop using the build metaphor. We need to start using about software development as what it actually is, which is knowledge work. And knowledge work is actually one of the activities that we are doing is refining knowledge. We get very vague knowledge in the beginning, vague needs and wants, and what we end up with is very precise code that we can run, that the computer can run. And all the knowledge necessary for the product, everything that we know about the product and that makes the product work necessarily has to be in the code, which means that there's something happening to the knowledge in the meantime. And what I like to call it is we are refining knowledge. So because of this, indeed, architecture, building metaphors, not that great. But there are a few things that we can take from architecture. I would not completely separate the act of designing architectures for software from the act of designing buildings as architects. There are still things that we can transfer from one domain to another. Okay, so it's a mixed bag. I agree with that. The work of architecting software systems is far more dynamic than the building architecture metaphor supports. Buildings are static and the work of building architects is done just once. Software by its nature is ever shifting and dynamic, and when it stops changing, it starts to die. That's true. It's true, although, so here's where I think that we are missing some point in relation with the building metaphor. What we are actually doing in software is the code that we are writing is a blueprint. The build process is actually done by a compiler. We are lucky enough that we have something that builds things for us, right? Imagine if for every change in software you need to call in a special team that actually uses some physical materials to build the result of your code, right? So the code that we write is actually a blueprint. So everything that we are doing up to obtaining the blueprint is actually an act of design. It's an act of first architecture and then design. Architects do the same, right? So what they do, they architect, they create the blueprints for the building, and then they pass it on to the builders, to the build system. Only in their case, the build system indeed, they need to get it right from the first pass, or there are some adjustments that they can make during the development, during the actual building, but they are not so large. Now in software we have a different kind of thing, which is because the build step is so cheap, we can actually build and build again and build again and build again. This means that it's much easier for us to move quickly and experiment and try out things and see whether they work and so on. All right. It's much more difficult for architects to do that, because for building architects, because they will need, if they want to test a hypothesis, they need to run some other types of experiments. They cannot actually make changes in the blueprint and say, okay, let's try using some, I don't know, some weird material this time for this skyscraper. Let's just see what happens. They cannot do that. With us, we can do that. We can do it very quickly. So you can see that there are some parallels, but there are also some delimitation lines. So I think the process in itself is kind of similar. With another thing that architects have, the building architects have in their advantage, is the laws of physics that are known. They can actually compute things before making, actually building the thing and seeing that it stays up. They can compute forces, they can compute, resistance of materials and how the building vibrates and all these kinds of things. Whereas us in software, we don't have these laws, right? What we have is the ability to experiment faster using code. Let's make a change in the code and let's see how it works. Let's try using RabbitMQ instead of what we are using now for queues and see how that works. These kinds of things, we can do those as experiments. So it's a bit more complicated than what they are presenting here. It's true, building, you only build the building once, but also the act of designing the building is based on years and years and hundreds of years of experience and empirical experiments and science, right? Whereas for us, software is ever shifting, and yeah, we need to pay attention to how the software will change, and we continuously need to change our software as new requirements come, because software, our product meets the users are interested in something else, we need to add more features, or there's competition that adds more features and we need to add those features as well, or something similar, or to attract people with another set of features and so on. So of course, software is ever shifting and dynamic, buildings are static, but you see, it's not that, okay, the building metaphor is not that great, but there are still things that we need to think more careful about, I think. Okay, to arrive at a better understanding of software architecture, we need to go back to the origins of the word architect. It comes from the ancient Greek word architekton, yes, chief builder, that's what it means. Architecture is created by people building things. The sense has become lost in the work of building architects, many of whom have never poured a foundation frame of building or run plumbing or heating pipes. Design and building have become separated. Not so in software, where how something is built influences what is built and vice versa. But you see, design and building have become separated in buildings for a few reasons. First of all, the skills required to architect a building, particularly at scale. I mean, you could probably build a small bridge in your backyard just through experimentation, right? Do the empirical thing and so on. But the reasons why we have architects in for buildings is that they can reduce costs, they can reduce risks, and this has become separated because what they are doing is they need to learn how to compute the different things, how to use the science that's behind it. We don't have that science in software. But there's also something different about software, which I will probably touch in a little bit, because I think I know where this is going. And the thing is, architecture is about strategic decision in software and for buildings as well. The decisions that building architects make influences a lot the qualities of the final building. You know, will it fall at the first earthquake, right? The same happens with software architecture. And one point that's contentious here is that you need skills in order to do software architecture. You need skills for strategic technical decision making. And I'm not sure, we'll see where this goes, but not every developer has these skills. All right. The building analogy has led some software architects to focus too much on structure and behaviors and not the decisions that produce those structure and behaviors. It's not that structure and behavior are unimportant, but they are the result of a thought process that is important to preserve if the system is to sustainably evolve over time. Yep. Knowing why someone did something is just as important as knowing what they did. Yes. What they did should be easy to see in the code if it is well organized and commented on, but the why is often lost. More or less. There's a whole area of software design nowadays which focuses on the so-called screaming architecture, organizing your code so that the architecture is obvious. It's clear what is the architectural structure. However, this is a bit tricky to do, and it's not possible. So I was talking about knowledge beforehand. We are refining knowledge from requirements all the way to code. Trouble is if you try to go the other way and extract all the possible knowledge from code, all the knowledge that is there, it's not always as easy. And you need to structure your code in a way that helps your business. And sometimes this requires the architecture to be very clear from the code, but sometimes it requires the domain to be very clear from the code. And the thing is, you cannot organize your code in such a way that all the types of knowledge that you are stored there will actually be available quickly, right? So what they did should be easy to see in the code if it's well organized and commented on. Yeah, I'm not so sure about that. I think you need something else. You also need the diagrams. You also need some documentation. The why is often lost. Yeah, so if you have this problem and you don't understand why some architectural decisions have been taken by somebody, have been made, why somebody made architectural decisions in the past or in the present. There's something called architecture decision records, or ADRs, that you should look into. I won't go into those, but search for ADR. The reason for this is that architectural decisions in software are rarely clear-cut. Nearly every architectural decision is a compromise between competing alternatives, and the merit of alternatives it's hard to see until you try a few and see how they work. I would go even further than that. In the book by Mark Richardson on software architecture, and I forget the name of the co-author right now, what they say is that the first law of software architecture is that every architectural decision has trade-offs. And the second law is that if you find a decision that doesn't involve trade-offs, you haven't yet seen the trade-offs. They are still there, but you haven't seen them. So every architectural decision is a trade-off. Knowing what was tried and rejected is more useful than knowing what worked. As an old saying goes, good judgment comes from experience, most of which comes from bad judgment. Yeah, I agree, but let's be real here. Even if I write these architectural decision records, which store the problem, alternatives, and then the solution that we picked and why we picked it and so on, we still won't be able to capture all the alternatives that we have ignored, because there's a bias in the decision. We won't see all the possible alternatives, we'll just see a few alternatives and pick from those. And how we pick those alternatives there's a bias there. The bias comes from the personal experience of the people who are doing that. Now you can fix this in a way, or you can alleviate it by using more people to make decisions. Unfortunately, this can lead to an unwanted side effect, which is design by committee, where you have a bunch of people making decisions that tend not to be the best ones, but those that are the common denominator of the group. So yeah, it's a good thought, and if you want to learn more about architecture, if you have a bunch of ADRs available, or if you have people who you can ask what decisions they made and why they made those decisions and what mistakes they made and so on, then yeah, absolutely do that, because you'll learn a lot from their bad judgments, let's say, or from the solutions that they discard. But these are not always visible. This is also one reason why software architects must still be developers. They can't understand or predict the forces at work in a system without developing and testing something. Software architect is not some sort of honorarium for people who have retired from active development but still have knowledge the organization found useful. It has to be more. The act of architecting requires sufficient knowledge of a system to frame useful hypotheses about quality attributes and the expertise to write code and devise tests, or work closely with the team members who can evaluate those hypotheses. Absolutely. I agree with everything they are saying here. With one thing is though important. In many organizations, these people who are architects will also need to communicate a lot. So, and I know they are going into saying that so architecting is a skill, is not a role. Now, here's the challenge. You need to be able to talk to testers and explain how the system will be tested. When we talk about software architecture, we are talking about big systems, right? We are not talking about a toy product that you are working on alone and so on. Then fine, absolutely. But usually when we talk about architecture, we talk about it in the context of an enterprise where you have a bunch of departments, where you have a number of people who are interested and who are stakeholders in the product. So every decision that you make, you need to be able to present it to business people, to product people, to technical people, programmers, to testers, to business analysts, to security experts, to IT ops or DevOps or whatever you're using to run your operations, and so on. And yeah, I mean, I agree. Ideally, you would have a bunch of people able to do that within a team, and this will distribute. The reality, yeah, doesn't happen that often. So the problem is the following: the software architect will need to do a lot of communication, and that takes time. So they won't be able to design, test, run experiments and so on by themselves. And so work closely with the team members who can. This is what happens most often. You have one or a few persons who know the system, who understand it, who can devise these hypotheses and define quality attributes and much more things. And when it comes to writing code, devising tests, they can either pair with with team members, or they can just delegate that work. Now, it doesn't mean that they shouldn't be able to do it. I absolutely agree that they should be able to do it, and they should still write code from time to time in the system. Particularly things like specific experiments and architectural tests and so on. So there's a bunch of things they can absolutely do, and they should, because the moment they stop writing code for that system is the moment where they understand less and less about the system. They can also sit down with developers from time to time, and this is something that I always advise architects: sit down with developers from time to time and understand what is how they are dealing with your architectural decisions. Can they use them? What are they struggling with? Do they understand the decisions? No. So it's very important to do that. But okay, I think we've talked about this enough. Let's see further. Architecting is a skill. Architect is not a role. Using a title like software architect sends the wrong message about the nature of the work. The reality is that lots of software developers do architectural work. They just don't recognize it as such. Yes. Anytime they make decisions about how to handle quality attributes, they are affecting the architecture of the system. Being more aware of how implicit decisions affect the ability of the system to achieve quality goals is the first step in improving the architecture of the system. Yeah, absolutely. That's one of the challenges in software architecture. Let's say you have a few people who can make these strategic decisions and so on. And you know that you need a certain quality attribute. Let's say you need very high performance in certain areas, and then you go and say, okay, so we need to use that algorithm, a specific algorithm in that part of the code. But then developers decide to do something different. And when do you notice this? Well, that depends on how close you are working with developers, right? You may notice it very late in the process when everything is already kind of, the customers have tried to use it or the users have tried to use it and it doesn't work. And that's a really bad thing. You haven't done a good job as an architect because you haven't explained and made sure that this decision was actually applied. Now, if developers can be aware about the impact of their small decisions, of the line of code that they write today on the overall quality attributes, then that's great. That gives you, you work with the team instead of trying to police. Well, you never police the team, but instead of trying to make sure that the team doesn't go astray, more or less. So yeah, that would be great. Is it always possible? I don't think so. That's the problem. These things are complicated. It's not as easy. So what kind of skills do people need to develop or improve the quality of their architectural work? There are a few. An increased focus on quality attributes. Yeah. These are key cross-cutting requirements that a good architecture should address. And they talk about scalability, performance, security, maintainability, supportability. There are probably about 30 or 40 that you can discuss and that you can get to in your, depending on what type of product you are working on. An ability to conceptualize and address system-wide concerns. Yeah. An understanding of the complete life cycle of the system. Yes. An ability to balance concerns and compromise. Absolutely. Trade-offs. An ability to learn from experience and synthesize new approaches. Now, here's the thing. This requires imagination. They are saying synthesize new approaches. Let's actually imagine solutions. How many developers actually have so much imagination to imagine to imagine new approaches? Not completely new approaches, but like vastly different approaches. Instead of writing your code, use an open source library or use a commercial product or use something else. This would be a common idea. By the way, in order to do that, you also need to understand what's available on the market. You need to understand how many, for example, how many different types of storage there are, and when you should use a SQL database versus a NoSQL database, and when you use a NoSQL database, which one of those offers the quality attributes that you actually need. And of course, as an architect, you need to go wide. because you cannot learn for every single product how it will work in a specific context. You can know that there are 20 different products and that they are slightly different in the way they work, and to understand the differences between them, but then you need to start experimenting and see which one works for your product. So this means that you need to go wide, while developers need to go deep. They need to understand how to write the JavaScript code with Node.js that can send messages to a RabbitMQ specific queue in a specific environment and so on. This is extremely specific to your product, right? Okay. An ability to demonstrate leadership, the ability to raise concerns, foster discussions of different perspectives, facilitate consensus. Okay. Let me go back to this learn from experience. We are also talking about standards here. You need to have certain decisions related to the internal standards that you use, yes. And those can change, but those are also part of the leadership that is architecture. Software architecture is about strategic technical leadership. Architecting means continuously exploring. Architecting modern software applications is a fundamentally explorative activity. Teams building today's applications encounter new challenges every day. This continuous exploration means that the architecture can be determined upfront based on past experiences. Okay. As an example of how exploration, right, I'm not gonna go into these examples. To me, this is absolutely obvious. It's one of the things that Agile software development recognizes, is that change is inevitable, change will happen. It's not that users are, or somebody from your company keeps changing their mind and they keep asking you for other things. No, change happens because the markets change, because there's competition, because there's a lot of actors involved and everything moves in certain directions. And and this is just one of the things. You also have change on the technical side. You get new products, you get new cloud offerings, you get new patterns sometimes. So you need to be able to learn continuously. And as we've discussed already, the way we do architecture, or we should do architecture, is by coming with these specific quality attributes that are very important, that are key attributes for our product that we are developing, and to start making experiments with various types of architectures, various types of structures, various types of servers, or different types of solutions, and figure out which are the ones that fit best our product. So these are, this is very, very important. You need to keep doing this. You need to learn through experiments, through iterations, through exploration, but also make decisions, and you need to make those decisions before you have the full knowledge, which is part of strategic decisions, but it's also because you need to move fast. You cannot wait to have full knowledge about a system before you make a decision. You can reduce the risks of making a decisions, yes, and you can also make sure that you can change that decision in the future if you apply certain patterns. But you will need to make decisions with incomplete information and sometimes revert those decisions. Make mistakes, learn from the mistakes. And this is what software architecture is about. And so the question is, can any developer do that? I don't think so. Software architecture as a discipline needs a makeover. Its image suffers from a lot of old ideas about what problems it needs to solve and how it should go about solving those problems. Viewing software architecture as a continuous activity focused on forming hypotheses about how the system will meet quality attributes, and then using empiricism to prove that the system meets them is the essence of continuous approach to software architecture. This is absolutely correct. Yeah, I agree. This is how software architecting should happen. Now, let's see what they say about people. What also needs to change is to raise software architecture from committees of people disconnected from development and to put it into the hands of the people who can actually make it real and executable, the developers. Only then will we achieve the resilience and sustainability that we need from today's applications. I agree up to a point. So one thing that is good and bad about Scrum is this insistence on having all the roles together in the team. So you have cross-functional team, and we call this team the developers. And that's absolutely cool. It's great because then you can talk about skills, right? When you want to see whether a team is cross-functional means it can develop independently something from beginning to end, all the features required for that product, or make the changes in the product that are required at that point in time. And so how you do that is you look at the skills that you need in each team and the skills that you have, and you try to make sure that you have all the skills in the team. Now, with this being said, there are a few skills that are more scarce than others. Today, some of them are data science. Data scientists, not as many as programmers, for example. Security experts, not as many as developers or as programmers. And we will always have these differences. I don't think we'll ever get to a point where we'll have this perfect combination of all the skills in all the teams, right? It's impossible. It's impossible because these things keep changing. So because of this, I agree that the people who are making architectural decisions should be very close to the code, should be able to develop, should be able to write code, should understand deeply what the system is about. But now the question is, how many of your people from the development team will be able to raise their skills at this level, at the level where they can go wide instead of going deep, where they can make decisions with incomplete information, where they can actually make decisions that affect many people for a long period of time, which is what strategic decisions are about. How many of them will be able to do that? And also how many of them will be able to understand the system at different levels of abstraction. So there are certain skills that are more scarce than others. And because of this, if you can do architecture within your development team, absolutely brilliant. Go for it. If it works for you, great. But don't underestimate the value of a person who is particularly interested and, let's say, fit to make these types of decisions. Still keep them close, still keep them working with a team. Avoid putting them into committees and in ivory towers and all these types of things. But I don't think we will ever get to a point where we don't need software architects as people. Right? We might get there in a few cases, but I don't think we'll get there everywhere. Because another thing happens. If you get somebody who is able to do that from your team, it's more value if they can help other teams as well. And then suddenly they are not working inside the team, but they are working as a support, as a consultant for multiple teams. And that's not a bad thing. It's just a fundamental optimization at a system level. So I understand what they are talking about, but honestly, I'd like to see this happening. It would be interesting. I don't think we will ever see this happening as they are saying. Let me quickly show you. So we have a few courses on software architecture that you might find interesting. And one of them is called From Developer to Architect. This is the mosaicworks.com website. From Developer to Architect teaches you the skills of being an architect. If you've just been promoted or if you've been working as an architect for a short period of time and you want to get better fundamentals, this is a very good course for you. Another one that we have is Architecting Microservices, on how to deal with microservices. The third one, Software Architecture Principles. This is for software architects who have done this for a number of years. But again, they want to get a stronger basis and understand what software architecture is about. So yeah, let us know if you find these courses interesting, and I'd be happy to work with you and discuss these topics in more detail. Thank you so much for watching. I hope you find this interesting and useful. This has been a reaction video to an InfoQ article about software architects and what it means as a role in the context of Agile, or do we even need a role? And as you've seen, my general conclusion is, if you can have the skills of software architecture within a developer team, great. My feeling is that you will notice that certain people are better at doing it than others, and they will tend to help multiple teams. And whether you call them software architects or something else, it's what they will actually do. Thank you so much for watching, and until next time, remember to think, design, and work smart.